Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at multiple choice questions under Doppler effect. Okay, yes. So now, without wasting any further time, let's just dive into it. It says a car travels at a constant velocity towards a stationary listener. Okay, towards a stationary listener. Very important. The car's hooter emits a sound of constant frequency as it approaches the listener. Okay, now let's take information that is very important. The frequency of the listener will be greater than the frequency of the sound source. Why? Because now it is approaching. Okay, it is moving towards the listener, so the listener will hear a higher frequency, even though the frequency of this one remains constant. The frequency of the sound does not change. It is constant. Okay, what will change is that the frequency that is detected, because as it moves closer, you are hearing more loudness. So hence we are saying the frequency that the person hears will be greater than the frequency that the sounds actually emit. It says, which one of the following statements regarding the frequency and wavelength of the sound of the hooter is correct as observed by the listener? Okay, now remember, frequency is inversely proportional to lambda, or rather wavelength. So it means now the frequency, so the wavelength of the listener will be less than the wavelength of the sound. Why? Because now as it is moving towards you, the wavelength now becomes short, because now you are hearing more loudness. So it means now, if it is sirening like that, it means now it takes a shorter time for the vibrations of the sound to move towards you. But if it is moving away from you, the distance now will be greater. Okay, take a lambda as the distance. The distance will be shorter if it is moving towards you, the distance between you and the car. But if it is moving away from you, the distance between you and the car becomes greater. So hence here I'm saying the lambda, or rather the wavelength that you feel, or the distance that you feel, will be less than the distance of the source. So both frequency and wavelength have decreased. No, the frequency will increase, but the wavelength will increase. The frequency has increased while the wavelength has decreased. Very correct. 15, number B. The frequency has decreased. No. Both have increased. No. The most correct answer is B. Let me try to zoom that out for us. The wavelength of light emitted by a distant star appears shorter with the wavelength. So remember, if the wavelength it is appearing shorter, it means now the frequency is higher when the lambda is shorter, meaning that this we call what? Blue shift, or the stars are moving, stars are approaching. Okay, or the stars are approaching. These are the things that we can conclude. They say when observed from the earth, from this we can conclude that the star is moving towards the earth and the light is blue shifted. Very correct. Very correct. Now the stars are moving towards the earth. Okay, if the stars are moving towards the earth, now the frequency is higher, and now the distance between the stars and the earth is becoming shorter. Okay, it is moving towards the earth and the light is blue shifted. Very correct, number A. Moving towards the earth and the light is redshifted, not redshifted, not redshifted. Moving away, not moving away, not moving away. So the most correct answer is A. 17. Which one of the following statements below about the Doppler effect is correct? Okay, about the Doppler effect. The Doppler effect is only applicable to sound waves. No, it is not only applicable to sound waves, because if it is only applicable to sound waves, we wouldn't know how now the stars, if they are moving towards us or are away from us. So it is not only applicable on sound waves. Okay, so it is not only applicable on sound waves. Yes. Okay. The Doppler effect can be used to explain the expanding universe. Yes. Remember, we are saying now, if the the stars or the spectrum lines are moving towards the redshift, we are saying now the universe is expanding, right? Yes. C, electrons are ejected from a metal surface by means of Doppler effect. This, if you haven't done, what's this? Photoelectric. This is just the definition of electrons are ejected from a metal surface. This is the topic of photoelectric effect. So this is wrong. Okay, this is photoelectric effect. A stationary listener hears a low pitch on the sound from a siren approaching. So no, the pitch will be higher. Remember, the pitch will be higher, the frequency will be higher, and the wavelength will be lower. So what? A stationary listener hears a lower pitch. Very, very incorrect. Very, very incorrect. So the most correct answer is B. 18. Which one of the following is not application of Doppler effect? Okay. A light meter. We do not have a light meter. We do not know that. We know a blood flow meter. We know a blood flow meter. So A is not applicable. So it means not. Can you see the answer is not applicable? So it means now A is the most correct answer because no, it's not applicable. Let's look at B. A blood flow meter. This is applicable because now we are measuring the speed of blood, detecting a fetal heartbeat. This we use. Measuring the speed of an approaching car. This we use. So these one are the ones that we use. Okay. From B to D, they are applicable. Okay, we also explained this on the video where we explained now a Doppler effect. The spectrum lines, the spectrum produced by a moving asteroid as observed from the Earth indicate that the light has shifted towards the blue end. Okay, so if it is blue shifted, the frequency is higher and the wavelength it is less. So it means now the distance. Okay, remember wavelength means the distance. So the distance is shorter like that. So it is moving towards us. Which one of the following frequencies? Okay. Which one of the following frequency combination and the observed light and the distance between the asteroid and the Earth is correct? Correct. Frequency increase. Frequency will increase. Distance between the asteroid and Earth, which is lambda. Okay, here they can say lambda, it is low. So number 19, the most correct answer, it is A. Okay, yes. Most correct answer, it is A. A stationary passenger at the railway station listens to a train approaching with a constant velocity. I know the pitch should increase. I know the frequency, that the frequency of the listener and the pitch of the listener should increase, and the wavelength of the listener should decrease because now it is approaching. If it is approaching, the distance between the two is less. So which one of the following is correct for the sound of an approaching train? Okay, heard by the stationary listener. Okay, now low pitch, no. Low pitch and low frequency, no. High pitch, very low frequency, no. High pitch, higher frequency, very, very, very correct. Low pitch, no. Here, the most correct answer it is C. A police car with its siren on is traveling at a constant speed towards. Can you see now these questions are repeating itself towards a stationary sound detector. The siren emits sound waves of frequency F and speed V. Okay. The what? Let me repeat. The siren emits sound waves. Okay, sound waves of frequency F and speed V. So remember the formula is V is equal to F lambda. This is the speed of wave. The speed of wave is always constant. The speed of wave is always constant. It does not change. What changes the frequency as well as the lambda. Okay. We are not talking about the speed of the car. We are talking about the speed of the wave. The speed of the wave is always constant. It is 340, depending on what the examiner gives you. So they tell us which one of the following combination best describe the frequency and speed of the detected frequency. So if it is moving towards, we know the frequency should be greater. But now the velocity does not change. The speed V, okay, which is the sound wave, okay? The speed of sound wave does not change. So the most correct answer is D. Number 22, the siren of a police car moving in front of a truck emits a sound waves of frequency F. So now the siren of a police car moving in front. So it is moving in front of a what? Of a truck. So let's say we have a truck here. I don't know how to draw. This is a truck here. Then we have a police car like that. Okay, this is a police car. They are moving. Okay, they are saying both the vehicles are traveling at the same constant velocity. So it means now, if they are traveling at the same constant velocity, it is the same as saying they are at stationary. Meaning now, the frequency that this one emits will be equal to the frequency that this one has. Meaning the frequency of the sound will be equal to the frequency of the listener. Because now it is not moving away, it is not moving towards. Why? Because now they are moving at the same speed. So whatever the sound that it hears, it will be the same throughout. Because why? They are moving, the distance does not change here. The wavelength is the same also. If the wavelength of the listener is equal to the wavelength of the sound is the same, the distance between the two is the same. So yeah, the question is the frequency of the sound heard by the driver of the truck is, the frequency will be the same as the frequency that is emitted. So they tell us emit sound waves of frequency F. So it means now the listener or the driver will hear the frequency of F also. Okay, the frequency will not change. So the answer is A for number 22. You could understand that it is not moving away. Okay, if the velocity was not the same and this one is speeding, yes, it means now it is moving away. But if it was moving slower and this one is moving faster, it is moving towards, something like that. You can see. So yes, that's all. Number 23, they tell us an astronomer observes that the light spectrum of a light has been blue shifted. What does blue shifted mean? We are moving towards a higher frequency. Okay. How have they observed the frequency of light from the star and the distance between the star and Earth change? This one we are repeating this. The frequency will increase and the distance will decrease. They are inversely proportional. The most correct answer is B. Number 24. Consider the two spectrum diagram. So this one is the initial one. Or they tell us diagram 1 represents the spectrum of an element in a laboratory on Earth. Then diagram 2 represents the spectrum of the same element from a distant star as observed from the Earth. So which one of the following can be deduced from the spectrum? Can you see initially it was here? Initially it was here. But here, can you see it moved towards this one moved towards the red side. It moved towards the red side. This also moved towards the red side, meaning now this is red shift. Can you see? But if it moved here, it was going to be blue shift towards the blue, but they are moving towards the red shift. So which one of the following can be deduced from the spectra there? We can say the star is moving towards Earth. No. Remember red shift, it means now the Earth is expanding, it is moving away from us. Okay, the spectrum moving away from us. The star is at rest. No, we don't know that. The star is moving away from Earth. Very, very correct. Very, very correct. Both the star and the Earth are moving towards our man. Not both of them. Remember, one should be at stationary, one should move towards or away. Which one of the following can be explained by the Doppler effect? Number 25. A stethoscope is used to listen to a person's heartbeat. No. Not a stethoscope. Not a stethoscope. A stethoscope is used by scientists, whatever the stethoscope is, but it's not used to listen the person's heartbeat, okay? We do not use scopes inside the lab or inside the medical field. We only use it as scientists, okay? No, this one is not. An echo is here. So we want to know which one explains Doppler effect, okay? An echo is heard when sound waves are reflected. No, an echo is just sound waves as well as transverse wave as well as sound waves. Grade 10 topic. The spectrum of light from an approaching star. Okay, so if it is an approaching star, it is moving towards the blue shift, or it is approaching, we know the frequency will be higher, but the wavelength will be short. So it's shifted towards the shorter wavelength. Very, very true. If now it is approaching, If it is approaching, we know the frequency will be higher, the wavelength will be shorter. We've been repeating this. Most correct answer is C. Sound intensity decreases when the sound source moves away from the station. Sound intensity decreases when the sound source moves away from a stationary listener. Now, we do not understand what the examiner means here, but let me repeat that. The sound intensity decreases when the sound source moves away from the listener. The sound intensity. Now, the sound intensity, it is another topic. Here we are talking about now frequency as well as wavelength. So the sound intensity, we do not know about that, okay? We do not know about now the sound intensity and all of that. We know about the frequency as well as the wavelength, okay? And we know that the sound will always stay constant, okay? The sound will stay constant. Number 26, light emitted from a distant star contains a spectrum line X of frequency F, okay? The spectral lines of the star moves or when observed on Earth are redshifted. So it means now the frequency will be low because now if initially it was F and it is moving away, the frequency will be low. We will detect a lower frequency or a smaller frequency than F. Which one of the following combination of the observed frequency of spectrum line X and the motion of the star is correct? So the motion of the star is now redshifted. It is moving away from Earth, okay? And now, remember, if you are redshifted now, the frequency will be low. So now the most correct answer here, greater than F, no, greater than F, no, smaller than F, yes, smaller than F, yes. But now, is it moving towards or away? It's moving away from us. Number 26 is the most correct answer. B, so number 27, a learner standing at a roadside records the frequency of sound waves produced by the siren ambulance. So now this is the detected frequency. So a learner standing at the roadside records. So the learner is at stationary. Okay, the learner is at stationary, velocity is equal to 0. And now is measuring the sound waves produced by the siren of an ambulance. The ambulance is moving at a constant velocity along the straight horizontal road. The frequency time graph of the detected frequency is shown below. Here, can you see now the frequency is low, so it means it is moving away. Here, the frequency is high, it is moving towards. I did this graph on the video that I recorded when I explained the concept of Doppler. I said, but the one I thought it said, okay, it started by moving towards, then as time went by, it went away. So it's like this car. Okay, what I'm gonna tell you, it's like this car was moving away and in a way it returned, okay? But I don't know what's the case here. But if the frequency here was low and then the frequency increased, it tells you that it was moving away, then it came back, moving what? Okay? Away and towards, something like that. So they tell us, I'm saying here, okay, before I go to the options, I said since while the frequencies away is less here, so it means it went that way because now the frequencies detected will be less if it is moving away. But can you see now there was a change. So that change tells us, so during that change, it maybe made a U-turn or what, but now the frequency now the learner here was now higher. So it means the car was moving in that direction and took a U-turn and went in that direction. So they say, which one of the following statement concerning the motion of the ambulance is correct? Okay, the motion of the ambulance. The first one, ambulance approached the learner and then passed the learner. If the ambulance approached the learner, it means the frequency detected should be higher. Then after that, if it is moving away, it should be low. So that is incorrect. The graph does not say that. Number B, it moves away from the learner, then turns and approaches the learner. Very, very correct. B, very, very correct. Okay. Number C, remember you should check all the options. Number C, approaches the learner, then turns and moves away from the learner. Aye. How can you approach the learner and turn and also move away? How do you turn and move away? Because when you turn, you should approach me, should come back. C does not make sense. C is not the correct answer. C says, D says, moves away from the learner. Moves away from the learner and then stops. Moves away from the learner and then stops. If now it moves away from the learner and then stops, it means our graph should be like this. Should be like, if it is moving away, like, I don't know, change a little bit, change, then become constant. Okay? Because now here, hey, I don't know, but there's no way. I think, I don't know. D, no. For me, this is not an answer. The answer for me is B. June, why am I saying June? 28, a train moving at a constant velocity towards, okay, frequencies are higher. These questions are repeating themselves. Frequencies are higher. Okay, let's read the full statement. A train moving at a constant velocity towards a stationary listener emits sound waves of constant frequency f. Okay, so now we know that the frequency of the listener will be greater than the frequency of the sound. Why? Because it is moving towards. So they say, which one of the following statements about the sound waves observed by the listener is correct? The observed frequency is higher than the emitted frequency. Very, very true. A, it is very, very correct. The frequency, the observed, remember the frequency observed is that of the listener. Okay, observed, the one who observes is the listener. So the frequency is higher than the emitted one. Very, very correct. Number B, the wavelength is longer. No. If the frequency is higher, wavelength is shorter. Frequency is lower. No. Wavelength is equal. We never know that. We don't have that. So the most correct answer it is A. So yes, that's all from me for Doppler effect multiple choice questions. Let's meet on the next video. Thank you.